In this class, we'll discuss about chylomicron metabolism. And this chylomicron metabolism is very important for the transport of exogenous lipids, exogenous triacyl glycerols. So, we'll take lipids in our diet, and these lipids in our diet, they are broken down into fatty acids and monoglycerides. And this breakdown is done with the help of a enzyme called as pancreatic lipase. Now, from the intestinal lumen, these fatty acid and monoglycerides, they are absorbed into the intestinal cell. After they are broken down, they are absorbed into the intestinal cell, and again they are converted back into triacyl glycerols, and these triacyl glycerols are transported to peripheral tissues with the help of chylomicrons. So these exogenous triacyl glycerols are transported with the help of chylomicrons to peripheral tissues, and these chylomicrons will have an apoprotein, that is B48, ApoB48. Why we are calling it as a ApoB48? Because only 48% of protein is encoded. And now these chylomicrons have to be assembled in the intestinal cell, and these chylomicrons, when they are assembled, they will carry triacyl glycerol, cholesterol ester, cholesterol, and fat soluble vitamins. And these chylomicrons will transport 90% of triacyl glycerols. That means these chylomicrons will contain 90% of triacyl glycerols. And these apolipoproteins and lipids have to be assembled into the chylomicron, and assembly and formation of chylomicrons is done with the help of a protein called as microsomal triglyceride protein. This is called as an MTP. So what it will do? It will load ApoB48 and lipid into the chylomicron. So what will be the structure of chylomicron? This is the structure of chylomicron, and this chylomicron will have ApoB48. This is ApoB48, and one more lipoprotein is incorporated onto the chylomicron, that is ApoA. This is ApoA, and this chylomicron will contain triacyl glycerol, which is greater than which contain more than cholesterol ester, and cholesterol esters are more than cholesterol. Okay, this is the ratio, this is the decreasing order, and 90% of the triacyl glycerols will be carried by the chylomicron, and this chylomicron is called as nascent chylomicron. And this nascent chylomicron is functionally incomplete. so they can't function, they cannot function properly. And these chylomicrons, nascent chylomicrons, will fuse with the plasma membrane, and they are released into lacteals, and these lacteals are connected to lymphatics, and these lymphatics will open into thoracic duct, and from thoracic duct they will open into left subclavian vein, and from left subclavian vein they are transported to systemic circulation, and they will reach peripheral tissues. Now we have said that these chylomicron which is released from the intestine is a nascent chylomicron, and this nascent chylomicron is functionally incomplete, and whenever this nascent chylomicron reaches the systemic circulation they are modified and they'll become fully functional. They gain the function whenever they reach the systemic circulation. So what will happen here? This is an intestine. In the intestine, chylomicrons are assembled, and these assembled chylomicrons will contain ApoB48, and this is ApoA. This is ApoB48, and this is ApoA, and they will contain more triacylglycerols than cholesterol esters than cholesterol. So this is a nascent chylomicron, and this nascent chylomicron is released into the lymphatics, and from lymphatics they go into the systemic circulation as a nascent chylomicron. So this nascent chylomicron is coming out of the intestine. This is ApoB48, and this is ApoA. So triacylglycerols are greater than cholesterol ester, greater than cholesterol. This is called as a nascent chylomicron, and this nascent chylomicron in the systemic circulation they will receive ApoC2 and ApoE from which molecule? HDL molecule. This is an HDL molecule. This is HDL, and these HDL molecules will have, one is ApoA, one more is ApoC2, and one more is ApoE. This is ApoA, this is ApoC2, and this is ApoE. So this ApoE will reach the chylomicron, and ApoC2 will reach the chylomicron. And now this nascent chylomicron will become a mature chylomicron. This is a mature chylomicron. How it has become mature? It has become mature by taking up ApoC2 and ApoE. So this mature chylomicron will have ApoB48, ApoA, ApoE, ApoC2. So this is ApoB48, this is ApoE, This is ApoC2 and this is ApoA. Here triacyl glycerols are greater than cholesterol ester, which are greater than cholesterol. Okay. Now, what is the function of this ApoC2? It will activate lipoprotein lipase, and this lipoprotein lipase is attached to endothelium by heparan sulfate. Whenever chylomicrons reaches the systemic circulation and whenever they reach the muscle, adipose tissue and heart, this lipoprotein lipase is released from the endothelium and it will degrade triacyl glycerol present in the chylomicron. So what it will do, lipoprotein lipase, it will break down triacyl glycerols into glycerol and fatty acid. So main tissues which take up these fatty acids are adipose tissue, muscle. It can be skeletal muscle or it can be heart. So when these fatty acids reach the adipose tissue, these fatty acids are stored in the form of triacyl glycerols. They are stored. These fatty acids are converted into triacyl glycerols and they are stored. Whenever they reach the muscle, they are utilized as energy. They are utilized for energy. So this lipoprotein lipase is present in the vascular endothelium, and whenever the chylomicrons reaches this adipose tissue, muscle and the endothelium which is present in the vascular vessels, these chylomicrons triacyl glycerols are broken down into fatty acids and glycerol. Now what will be the fate of the glycerol? This glycerol will reach liver, and this glycerol will have two fates. They are converted into, first they are converted into dihydroxy acetone phosphate, and this dihydroxy acetone phosphate, they are used for gluconeogenesis and they can be used for lipid synthesis. Both can be done. Okay, this is the fate of glycerol whenever it reaches the liver, either gluconeogenesis or lipid synthesis. Now this mature chylomicron is losing its triacyl glycerols and they will become, this size of the chylomicron will decrease. This chylomicron size will decrease because most of the triacyl glycerols are broken down by the lipoprotein lipase into fatty acids and glycerol. Now this chylomicron doesn't have triacyl glycerol, and the chylomicrons will have cholesterol esters greater than cholesterol, and the size will decrease. But what will happen? This size decreases and density will increase. Okay, now this chylomicron will donate this ApoC2 ApoC2 and ApoA. This Apo this is ApoE. This ApoE is again donated back to HDL. So ApoC2 is donated back to HDL and ApoA is donated back to HDL. Now this chylomicron will have only ApoB48 and ApoE. They will have only ApoB48 and ApoE. And this chylomicron is called as remanent chylomicron. Remanent chylomicron. Now, these remanent chylomicrons will reach liver, and in liver we have ApoE receptors. ApoE receptors. Now, these remanent chylomicrons will bind with these ApoE receptors and they are endocytosed. So, this remanent chylomicrons will bind with ApoE receptors in liver, and after binding with the ApoE receptors, these remanent chylomicrons are endocytosed, and they will fuse with lysosome, and in lysosome these remanent chylomicrons are degraded into free amino acids, free cholesterol, and fatty acids. And these ApoE receptors are recycled back to the membrane, and again they will participate in one more cycle of getting back the remanent chylomicrons into the cell. So this is a receptor mediated endocytosis. These remanent chylomicrons are absorbed through the receptor mediated endocytosis, which is almost all similar to LDL metabolism. And this is how exogenous exogenous triacyl glycerols are transported through the chylomicrons. And this is the end of the class. Thank you.